Question 7 says, on Monday, the amount of money spent on a website by each customer was recorded. The table shows the results. So we have class intervals for amount of money, and then we have the frequency values. So as you can see, we have an unknown frequency value, which is P for the 0 to 30 interval. The histogram shows some of the results. So we have the frequency density on the y-axis and amount of money on the x-axis. Find the value of P. So if you look at the frequency density for 0 to 30, that is 1, 2, 3, 4, 5. That's 0.5. So frequency density has the formula of frequency over class width. So frequency density for 0 to 30 interval is 0.5. Frequency is P, and class interval is the difference of 30 and 0, which is 30. So that means 0.5 times 30 is going to give us the P value, which is 15. Then it says complete the histogram. So let's find the frequency density for each class interval. So for 30 to 40 is already made. So we need to do the last three ones. So for 40 to 50, frequency density is going to be 24 over 10, which is 2.4. Then next one is going to be 19 over 10, which is 1.9. And the third one is 24 over 30, which is going to equal 0.8. So we're going to mark these over here. So for 2.4, that's going to be 1, 2, 3, 4. Just going to draw a line over here first. So that's from 40 to 50. This is 2.4. Next is 1.9. So 1.9 is going to come over here. So 50 to 60 is this. And lastly, 0.8. So that is all of this. I'm going to remove this. So this is your complete histogram. Then they're saying one of these customers is selected at random to receive a discount voucher. Calculate the probability that this customer spent more than $50 on Monday. So more than $50 is 19 and 24. These are the people. So that's going to be, and the total was, we don't know the total frequencies. We have to find that first. So let's start with the total frequency. So we know P was 15. So let's find the total frequency, which is going to be the sum of all of these values. So 15 plus 18 plus 24 plus 19 and plus 24 again. That is 100. So greater than 50 is 19 and 24. So our probability will be 19 plus 24 over 100, which is going to be 43 over 100 or 0.43. The table shows the amount of money spent on a website by each customer on Tuesday. Calculate an estimate of the mean. So this is going to be our X value. This is going to be our F value. So let's start with finding the midpoint of our intervals. So for X, value for the first interval is going to be 15. This is going to be 35. This is going to be 45, 55, and this is going to be 75. So now what we do is we use these x values to find sigma fx. Sigma fx is the sum of the product of frequency and the x value. X is your mid value of the class interval. So that's going to be 15 times 22 plus 35 times 16 plus 45 times 24 plus 55 times 19 and plus 75 times 14. So that's going to equal, that's 4065. Sigma f is going to be the sum of frequency. So that's 22 plus 16 plus 24 plus 19 plus 14. That's 95. So mean is going to be sigma fx divided by sigma f, which is 4065 divided by 95, and that is going to equal 42.8. Second part says an error was made and one of the sales on Tuesday was not included in the table. That customer spent $41. Tristan says if that value had been included in the table, then the estimated mean would have been higher. Without explanation, explain why he is correct. So if that value was included, it would be included in the 40 to 50 interval. And your mid value in this interval is 45. If the 41 value was a part of this data set, our frequency value would be different then, because there's one more value in this interval. So since the frequency value would change, that would change the overall estimated mean as well. Because for that class interval, there's a higher frequency, which changes the total frequency and the fx value of that class interval. Mid value would still be the same, but it's the frequency value that's changing. Hence, the estimated mean would have been higher than.